What's going on, everybody? Mr. Gustin at home battling COVID. Me and Grace are here. Feeling good, doing good, just can't come to school yet. So I thought I'd give you some notes on some KEQ stuff and what we're going to call ice tables. So before we do it, go ahead and do that. Let's review a little bit. We remember from previous units that concentration is equal to the number of moles of something divided by the liters of the container that it's in. That's an important thing because we're going to need concentration here when we talk about our KEQ tables and our ice tables. So when do we use this method of solving things? Well, we're going to use this ice method when we are not at equilibrium yet. So we'll see as we read these problems what that looks like in terms of words and how we know when to use ice. Up until now, we've been saying there are things at equilibrium. Let's write KEQ expressions and let's go ahead and calculate things based on that. What this is basically saying is if I've got some reactants and I put them into a vessel and they're allowed to react, what will happen and what will it look like when it finally does reach equilibrium? So that's what we're going to be using this ice table method, okay? Let's go ahead and look down at our steps here. The first thing, our first example we're going to consider is hydrogen gas reacts with iodine gas to form an equilibrium with hydrogen iodide, and it's a 1 to 2 ratio. In this problem, we're told a few things. So the first step we're going to do is make sure that we write down everything we know and that we're told. So we're told that there's 0.5 moles of H2, there's 0.2 moles of iodine gas, and these are both in a 2-liter flask. And I'm asked to find at equilibrium, or I'm told at equilibrium, HI has a 0.08 molar concentration. I'm asked to find the value of KEQ. That's the equilibrium constant. So I need to find equilibrium concentrations for H2, for I2, and for HI, which I'm already given. So first step, let's go ahead and convert these moles. Since it's in a 2-liter flask, let's convert them into their concentrations. And we can do that pretty easily. Again, we just reviewed that. A number of moles per liter is concentration. So 0.5 moles of H2, a 2-liter flask, that's going to give us 0.25 molar of H2. Iodine divided by 2 is 0.10 molar. That's the initial concentration that we have here. So we've already gone ahead and done that. So initially I put 0.25 molar, that's the concentration of H2, and 0.1 molar iodine into a 2-liter flask. And they're allowed to react until they reach equilibrium. At this point, I want to go ahead and figure out, okay, using stoichiometry and some multiple ratios, I want to figure out how much they're going to react until they reach equilibrium. This is where the ice table comes in. All right, so I'm going to go ahead and put my ice table over here. At the top of my ice table, it's important to rewrite my chemical reaction in equilibrium with 2HI. And I'm going to have 3 rows, 1, 2, 3 columns, and there's a column for every single chemical involved in the equilibrium. So if there are 4 chemicals in the equilibrium, I'd have 4 columns. But we're always going to have 3. And these 3 rows, and these rows are called I, C, and E. And what these stand for are initial concentration, change in concentration, and equilibrium concentration. That's what these terms stand for. So we're going to start filling in the table with what we're told and then see where to go from there. Okay, so initially we have 0.25 of H2. We have 0.10 of I2. And because this is where we start, we don't have any product yet. We have not been given anything over here. They're going to react to make HI, but there's nothing there yet. Okay? We're also told that at equilibrium, this is in the problem, it tells us at equilibrium we have 0.08 molar HI. This is all I know so far. But I also know a couple other things, right? Like if I start with 0 HI and I end up with 0.08, that change is what belongs there, right? The change in concentration is going to be a positive 0.08 molar. I started with 0, I ended with 0.08. Well, the change must have been a positive 0.8 molar over there, okay? So that's what belongs there. But I don't exactly know how much change happens here. So I'm going to call those x values or variables, all right? So let's think about this. I'm going to lose some amount of H2, and I'm going to lose some amount of I2. I'm going to call those x's. Now, also, I could, and what I want to do is I want to figure out how much HI was gained. So if I lose X here, again, these are mole-to-mole ratios, right? So for every one H2 I lose, I'm going to lose one I2. We'll call these 1X and 1X. How many HIs are made? Well, I make 2X HI. Where does that come from? It comes from 1 mole of H2 reacts with 1 mole of I2 in equilibrium with 2 moles of HI. So I lose 1X. I lose 1X to make 2 HIs, or 2X. So off to the side, I can make an equation. I can say, hey, 2X is equal to 0.04. I know that, and it's hard to see on the screen, but I know that because I gain 2X over here, and I end up with 0.08, okay? So I've already gone ahead and kind of solved what X is going to be. So let's write that in here. So I start with at equilibrium, I have 0.25 to start, and I lose 0.04. That means at equilibrium, I am left with 0.21 molar H2. I started with 0.10. I lost 0.04. So at equilibrium, I have 0.06 molar of I2. These are now my equilibrium concentrations. This is how I use an ice table. I put in my known information. I use a little logic to figure out the changes in equilibrium, and I'm left with my equilibrium concentrations of 0.21, 0.06, and 0.08. And the question asks me to determine KEQ. I'm pretty good at this. We've been doing this for a while. KEQ, let's go ahead and write the expression. The expression is always products over reactants. So my products are HI, concentration of HI, raised to its coefficient, which is 2, so HI squared, divided by H2, multiplied by I2. Don't make the mistake of adding these. Students always want to add these values together. It's a rate law, so it's a multiplication or a product of the two concentrations. Certainly not a sum. We're not adding here. So step 3 is to write my KEQ, and there it is. Hopefully we're old pros at that by now based on the practice we've done. Step 4 is solve it. So find me KEQ. Well, I already know my equilibrium concentrations. That's the E row in my ICE table. So since I know those, let's go ahead and plug in and solve. KEQ is going to be equal to 0.08 squared divided by 0.21 times 0.06. These are my equilibrium concentrations that match the chemicals that I have in my KEQ. Now, with good calculator skills, hopefully we end up with the same answer. My answer here is 0.508. There you go. So, this is the answer to the example problem. Let's review on what we have to learn, or what we have learned here. We reviewed that concentration is equal to the number of moles per liter. And that's important because in equilibrium, we're always talking about the concentration of chemicals. We're going to use ICE tables when we are not at equilibrium yet, when we're said to be at initial conditions, when I told you what is put into the equilibrium and then allowed to react. That's when we use our ICE tables. How do we start? We write down what we're told. We convert them over into concentrations. We build our ICE table. We use a little bit of logic to go ahead and fill out the ICE table to find our equilibrium concentrations. And then we use our KEQ expression to find KEQ. Now these problems might get a little harder. I might give you the KEQ and ask you to find some equilibrium concentrations. I might give you some equilibrium concentrations and ask you to find initial conditions. Who knows? They might get different, but the same process applies. Write down what you're given, convert them to concentrations, use your ICE table and KEQ as tools to go ahead and solve the problem you're given. So go ahead, work on the rest of the sheet. I'll have a key posted to Canvas. If you have any questions, email me, but rely on each other, rely on this video, and rely on your critical thinking skills as students to go ahead and complete this worksheet. See ya.